Hello everyone. Today's problem is longest subarray with majority greater than k. Difficulty having the medium. In problem it says that given an array ARR and integer k, the task is to find the length of the longest subarray in which the count of the elements greater than k is more than the count of the elements less than or equal to k. Here it is given very bit confusing, means little confusing here. So we will understand this by example. Now here we can see there is a given the example 1 2 3 4 1 and k equal to 2. We have to return the subarray where in that subarray the number of elements which are greater than 2 will be more than the number of elements which are equal to or less than 1. Here 2 3 4 and 3 4 1 are 2, both satisfy the condition. How? 2 which is equal to 2 means count is 1, means this element is equal to 2, and here the element which are greater than 2 are 3 4, means here the elements which are greater than 2 are greater than the elements which are equal to or less than 2. So here 2 3 4 is, it satisfies the condition and it is the longest subarray 2 3 4. Also 3 4 1, here 3 and 4 which are greater than 2 and 1 here which is less than 2. So here number of elements which are greater than k means 2 are at 3 4 which are greater than number of elements less than 2 which is 1 is less than the number of elements greater than 2. So both are the eligible, both are the valid. So if the longest subarray will be 2 3 4 or the 3 4 1, it means the size 3. Also we can see here the number of subarray in which number of elements where it will be greater than 2 and number of elements which are greater than 2 will be more than the number of elements which are less than or equal to 2. Here 6 is greater than 2, 5 is greater than 2, 3 is greater than 2 and 4 is greater than 2. So entire array, also the subarray, is valid because all the elements are greater than 2 and which is greater than the number of elements which are equal to or less than 2, because there is no element which is less than 2. So entire array is valid, so we are returning 4. Expected complexity is big of n and big of n. Topic tags are given, prefix sum and hash. Let's understand the example on the board first. So here 2 3 4 and 3 4 1 are two valid subarrays which satisfy the both condition. How? We see here 2 and 3 and 4 are the both elements which are greater than 2. So these are the two elements, and 2 is the element which is less than 2, which is 1. So here 2 is greater, means elements greater than 2 are more. So this is the valid subarray. Now here the elements which are greater than 2 are 3 4, so which are 2 elements, and elements which are less than 2 it is 1. So and here also the 2 is greater, means number of elements which are greater than 2, greater than k is more. So this both are the valid subarrays and we want longest subarray, so we are returning 3. What if, and as we see in the last example, here all the elements are greater than k itself, so we will return the entire array length. Now we will now see thought process and approach. As given in the we saw the topic tag, so here given the prefix sum and hash. So now we know we have to do something in the prefix sum and hash. So here we are using the simple thought process and the approach. We will do first array transformations. Array transformation means the element which is greater than k, we will mark it as the element which is greater than k, we will mark it as 1, and the element which is less than or equal to k, we will mark it as -1. So array will get convert into 1 and -1. This will be the array transformation. And prefix sum and hashing, as we know, we have seen the problems like the longest we have seen the problems like means longest subarray having the sum k, longest sub array and having the sum k, and the longest sub array which are longest sub array having positive sum, and longest sub array having longest sub array having sum k. So we have seen this kind of problem, longest subarray having sum k, in which we preserve all the we do the prefix sum and preserve in the hash map, and every time we check that k minus means remainder exist in our hash map or not, and this is the longest subarray having positive sum. We are going to add we are going to add approach of this both problem to form the approach of this problem. So what we are going to do, we are going to do array transformation first, and after that transforming array into 1 and minus 1, we will be using prefix sum and the hashing. So what will we do? Let's see. Here it is the code given. What the code says, let's understand that. This is the n, which is we have taken the array size. This is the vector. This vector is only for making the transformation. Look here, if the array of I is greater than k, then we are pushing the 1, which is the positive one, and if array of I is less than or equal to k, then we are pushing the minus 1. Means we have transformed the array and we have created the array in the form of like this. We have created the array in the form of like this. This is the array transformation. This is the array transformation which converts the array into 1 minus 1 from this. So this is the array transformation we have done here. This is the array transformation we have done from this code itself. Okay, start. Yes, we have done the array transformation from this code. Means if 1 is less than 2, so minus 1, 2 is equal to 2, minus 1, 3 is greater than 2, 1, 4 is greater than 2, 1, 1 is less than 2, then minus 1. So this is the transform array. Now here it was the array transformation part. Now here the prefix sum and the hash map. Now we will dry run the code. Let's first only understand the code. Here we taking the sum. Every time we are adding the sum. If the sum is 0, means sum is greater than 0. Means sum is greater than 0 means we have the positive sum. Positive sums mean, if we have the positive sums, means number of positive 1 are greater than the negative 1. Mean that condition we want now. If the positive ones are greater, means the number which are greater than the 2 are greater, then this condition works. If the sum is itself positive, then we are directly adding the I plus 1 to the length of the subarray. This is the condition which tells that if our sum gets positive, means number of plus are more than number of negatives, so this condition executes. Now here in which condition, in this condition we explore the hash map or hash map, in which we find the sum minus 1. Why sum minus 1? Because if sum minus 1, we found out the sum minus 1, means sum minus 1, and if we suppose, let's take the example, if the current value is 8, okay, and then previous value is 7. If the current value is 8 and we do 8 minus 1, so and we found it in the hash map 7, so we can say someone came here and make it 8 from 7 to 8 because it added plus 1, and we want how many plus 1. So if someone came and made it from 7 to 8, then plus 1 came and make it plus, means number, means in that index, both index sum minus 1 and sum, there will be chances of the plus 1. So this condition tells that sum minus 1, this is the most important conditions. So this is the heart of this algorithm. Sum minus 1, which tells that someone has come and make it as a plus 1, or make it as a, means if we can calculate the length of the subarray if it exists. You can see here I is equal to mp sum minus 1, and we are preserving all the sums in the hash map along with the indexes which are required here. And why we are checking if the it is already exist or not? Because we want the longest. If it already exists, we will keep on the same index and we will not change it. But if does not exist, then we will put it in the hash map. Now let's understand the code. Now try run the code. Okay, now let's make the hash map first. This is sum variable, and this is max length variable. Now we are here. Now we are here, and this condition, now we are here, and we already we transform the array. We are doing dry run on this example, and this is the transformated array of this example. Okay, transformated array. Now we will start from here. Here the sum initialized with 0. Maxi is storing the final length of the array, where it initializing with 0, because if the array does not exist, we have to return 0. So we are already preserving the 0. Then we are this is the crucial step we should always do. We are putting 0 in the map with the minus 1 index. We are putting 0 in the map with the minus 1 index. So let's now we go under the loop. We are coming under the loop when sum is equal to sum plus vector of I. This is vector of I. It gets minus 1. So it gets minus 1. Now the condition comes here. Sum is greater than 0. No, this condition comes here. mp dot find sum minus 1 is in the map. Sum minus 1 is in the map. Sum minus 1 is minus 1 minus 1 minus 2 in the map. No, condition get false. Now sum is in the array. The sum is in the map. No, sum is not in the map. So we are putting the sum in the map. So minus 1 is the sum and 0 is its index. Now we are going further. Oops. Okay, sorry for the disturbance. Now we are going further, and okay, remove this first. Okay, remove this minor. Okay, now we come to 1. We come to here 1. Okay, now what the sum gets? Previous it was minus 1. Previous it was minus 1, and plus now minus 1. It becomes minus 2. It becomes minus 2. It becomes minus 2. Now we will find out if the sum is greater than 0. No, sum is minus 2. So this gets false. Now we will see this condition. If find sum minus 1 is in the map. Sum minus 1 means minus 2 minus 1 is minus 3. Minus 3 not in the map. So this condition also fails. Now this condition, sum is in the map. No, sum is not in the map. So we will put the sum in the map. Minus 2 minus 2 and index is 1. Index is 1. Now the next iteration, we go to here. Now go to here. Now we again add the sum plus 1. Sum plus 1. Our sum was minus 2. Our sum was minus 2. Now it will become minus 2 plus 1 it will become minus 1. Now sum is minus 1. Now Now we are checking if sum is greater than 0. This condition already gets false. We are checking if MP consists of sum minus 1. Sum minus 1 means minus 2, minus 1, minus 1, minus 2. Yes, it exists in the map. So we will what we do, I minus MP of sum minus 1. What is I? I is currently, let's write down the I first. 0, 1, 2, 3, 4. Okay, now what is the I? The current I is 2. Current I is 2, and MP of sum minus means MP of minus 2. MP of minus 2, what will it will be? It is 1. So our length become 2 minus 1 is 1. So it is the length that we got. After that we have minus 1 as a is in the map, so we won't execute this step. So we will move further. We will add plus 1 to the sum. Then it will become the 0. After adding, it will become the 0. After getting 0, we will check this condition. If it gets no, it is not greater than this, then we will check this. If 0 minus 1 exists, yes, 0 minus 1 is minus 1. Yes, minus 1 exists. So we will take its, then we will take the current index, which is 3. 3 minus, what is 0's index? 0. We will take, yes, we got the length of the subarray is 3, which is greater than 3. We will replace it by 3. It becomes 3. After that we will see next, which is minus 1. After adding it minus 1, it becomes minus 1. After that minus 1, we will see if the minus 1, minus 2 exists in the map. Yes, it exists. Yes, minus 1, minus 2 exist. Again we will do the I minus MP of sum minus I, which is I is 4, and MP of sum minus I is 1, which is again equals to 3, which is 3, which is our length of the maximum subarray. This is the dry run, and how this is the code work. But what will happen, let's suppose take this case. When will we do dry run for this case? What will happen is, here the all things will be 1. Here all will be 1. So here what will happen, the sum will be 1. Sum will be always 1. So this condition will always get executed. This condition will always get executed. This condition is most important. Sum is greater than 0. This condition is most important here. This condition will always get executed, because sum is here. Here sum is getting 1. Here is getting 2. Here is getting 3. Sum is getting 4. When sum comes here, it will be 4. If sum is greater than 0, means it will 4 plus, it will get 3 plus 1 equal to 4. So 4 will be the maximum length of the subarray. And here the time complexity will be big of n, because we are traversing the whole array, and the space complexity is big of n itself, because we know we are taking the help of the hash map, we are making the transformation of the array. So this will be the time and space complexity. Now let's run the code. I have given this everything in the code and written in the code. Let's run the code. And let's submit the code. Yes, all test cases are passed, and successfully we solve the problem. Thank you so much for watching.